Hi. If I asked everyone to get up and stretch, how many people would actually get up and stretch? Let's do it. Let's do it. You've been sitting here for an hour and a half. There's four talks. All right, this is great. This is great. You know, there's two kinds of conferences. There's table conferences and there's chair conferences. You see how you all have tables in front of you? With your laptops? Professional conferences have tables because you guys all have real work to do. This talk is a bit more of the chair conference variety, but hopefully you'll enjoy it anyway. All right, have a seat, have a seat, have a seat. I'll stretch too, you know? All right. So yeah, I'm here to talk to you today about timeless debugging and a bit more. So I play a character named geohot on the internet. I was the first person to unlock the iPhone when I was 17. Those lights are really bright. I made jailbreak software called Black Rain that was used by 21 million people. It was great. You plug in your phone, you click the Make It Rain button, and you could jailbreak your phone. I also got sued by Sony for hacking the PlayStation 3. Why do I do this? Why do this stuff? Well, companies spend millions of dollars to make really cool puzzles for me to solve. I mean, it's true. That's how I see it. So I did the geohot stuff for a while. I got sued by Sony, and then I was like, you know what? That's getting played out. I kind of think of myself as a performance artist. So, you know, that's played out. You go to a stand-up comic, you hear the same, shtick again, and you're like, yeah, this is old stuff, right? So you need new stuff. Tom Cruise, I played on the PPP for a while. I was on the team for both DEF CON victories and one DEF CON second place. I showed up a day late. It's true. I was at Carnegie Mellon, I was playing these things, and then I'm like, how much harder are real programs? So about 2 weeks before Pwn to Own, in, I think it was 2013, I took a look at Adobe Reader. They were offering $70,000 for Adobe Reader. And I'm like, come on, how hard could this be, right? And it was easy. It was super easy to break into Adobe Reader, but it turns out Adobe Reader now has a sandbox. And Adobe didn't write the sandbox. Google wrote the sandbox. Very good sandbox. But you know, I like winning. I really like winning. I'm a big fan. And I wanted to win, so I kept. My time isn't ticking. Yeah, whatever. So I kept going at it, and I looked at. Adobe fortunately added API calls to the sandbox, so I figured that would be a good place to look. And sure enough, there was this very cute handle double free that I could leverage into breaking out of the underprivileged process into the high privileged process, and won $70,000 and an Acer laptop. The next year's laptop was much better. 2014, I was like, let's just take this by storm. And I did a full stack 0-day for the Google Chromebook. I believe the first person to achieve a persistent root on the Google Chromebook. And I got done 2 days early. Adobe was down to the wire. I was in the hotel room the night before, and I'd never written Windows shellcode in my life before that night. It's true. And I'm here, and I'm like, wait, what, I don't make syscalls? I have to write something to traverse this little PEB table and figure out where it was insane. You know, and I was told the next day that I could have, my shellcode actually wrote a DLL out to the system and then load libraried it. I could have just load libraried from a network share, you know. It would have made my shellcode a lot shorter, but it was 4 in the morning in a hotel room in Canada. But yeah, so this was the next year. I got done early. I had a beautiful, actually Google patched it 2 days before Ponium, and I was horrified. I didn't realize this till the morning of. I got there. It turned out the exploit still worked, but I had a few days extra, so I figured, why not try Firefox? Firefox, at least circa 2014, was about on par with a hard CTF problem. It took me 24 hours. 24 hours, full 0-day in Firefox. A lot of people use this browser. Don't use it. Use Chrome. Chrome is quite good. Even though I broke Chrome, you get paid a lot more money for Chrome. Chrome is quite good. So let's get to tools, right? I'm here to talk about tools. That's enough about me. GDB is terrible. We've been using the same paradigm of debugging for years, and I think GDB was written in, what, the 70s? It's the same paradigm of debugging for years and years and years. How can we do it better? For example, let's say we want to do root cause analysis on something, right? We have a proof of concept that can reproduce the crash. We want to figure out why it crashed, and we want to do this really quickly. You know, you're getting in tons of crash reports. You want to see, what is this? GDB gives you a backtrace, and it's kind of okay, but usually you'll end up having to run the program like 10 times because you forgot to set a breakpoint somewhere. Once you pass a point in GDB, there's no way to go back. They're trying rewind stuff, but even rewind stuff isn't what I'm talking about here. I'm here to talk about timeless debugging. GDB, very linear in time. think of the first time you used IDA. How many people here have used IDA? All right, that's good, that's good. A lot of people use IDA. Think about what came before IDA. There was objdump, right? You literally used to take objdump. Maybe you would cut out the basic blocks. You'd get a big piece of corkboard. You'd pin them up, you know? Maybe draw the lines. Different color thread if you're really getting fancy for whether the jump is followed or not, right? So IDA kind of made that corkboard for you. It's actually quite a nice tool. But there's been no equal advance in dynamic tools. Now, fine, if you're developing on the latest .NET, Objective-C, Swift, I'm sure you have a very nice debugging environment. But I mean actually for debugging binaries, which is what a lot of stuff still is. So in the theme of this being a TED Talk, now think of what is possible. So 2014, after my podium win, I was invited to come be Project Zero's first intern. So as an intern on Project Zero, really a great team, really doing great things in security. If you all haven't seen it, check out the blog. I still read it. It's one of the last things I still do, kind of security related. But I was on Project Zero, and they gave me free rein for a summer to come and develop something that was hopefully better. So here's the paradigm. Version control. I assume everyone knows what version control is. And you can, if you have like it's a layer kind of that sits on top of a file system, right? And it lets you, for each file in a certain version-controlled directory, see the entire history of that file, see the order in which changes were made, see who is to blame for one of the lines in the file, right? So it's a very developed set of tools. What if we could make the same tool, but instead of for files, for like memory and registers? Every instruction is kind of like a commit, right? The instruction's going to make some changes. Like say you have move R0, 1. Well, it's storing into the R0 file the number 1, and that's like a commit, and it happens at a certain time. So you take this, and you run with this idea. How can you make a nice, it's really a UI. It's a UI to explore traces. But if you do this powerfully enough, instead of that GDB cycle where you run over and over and over again, the same program because you missed setting a breakpoint, it's completely timeless. So this is my tool called Kira. You can see a program trace on the upper left. You can see the vertical timeline all the way on the left. That's like a trace through the program. Those yellow lines are times when that selected data address, if you see in the hex dump down there, was clicked on, was written to. We have IDA-like graph view, and we have the registers right there. So it looks pretty much like a traditional debugger, but wait till you see the demo. Things like this. Where was EIP, right? If you're in GDB and you know that EIP is on the ret, you have no idea which fork it went, right? I mean, this is the simplest thing. It should be recording, the last 10 instructions were this. We actually record the entire history of the program, but yeah, follow that trace, right? Type information. You can get so much type information at runtime that there's no way you could get statically. Like there's actually no way sometimes to tell what the type of something is statically. Dynamically, well, you know what function allocated it, right? And then you can detect, you can visually see things like use after freeze so quickly. So let's try this. I got a demo. Probably not going to work, but we'll see. OK, so here we are. We have a tiny little program here. Right? So if you want, it's like a little crack me. If you wanted to, we can run it here. Whoops, demo 1. So number, whatever. So you could do this with GDB. You could set a breakpoint on the if answer equals guessed, figure out what the answer should be, and do it like that. Or you can use Kira. So I'm going to start up Kira with demo 1. The cool thing about Kira is it takes it's the same API as like strace or GDB. I can just run Kira bin ls. The whole UI lives in a web server, so you just connect locally to port 3002. And this is a full trace of that run of ls. So if I click here, all these red lines, so this instruction at this address was hit every time you see a red line there. I can navigate between them, right? Works fine for big binaries, but let's try it on a little something smaller. So let's go back to our thing here, right? This is going to run it. It's going to bind it to a socket. So every time I connect to port 4000, I'll get an instance of this demo. So I'll go here, I'll netcat in port 4000. And number, let's just say 123. Nope, 123 is the wrong answer, right? So in a debugger, you've already lost your chance to see anything. The program's already terminated. But fortunately, we were running in Kira. So let's go here, back here, and let's look at main here. All right, so here you go. You have the control flow of that program. Is that visible? You have the control flow of that program here. So if we click down here, you can see that the code execution went that way. There's the word nope, and there's the word winner, right? So here's that compare. I can click on that compare. I can see right here that 7b was the value in EAX. Can you guys see this? Try to zoom in. So the value here, 7b, was that 123 that I typed in. You can see it in EAX. And it looks like it also did a load from this stack address, which we assume was the correct answer. This hex 500 here, right? So we've hit that instruction one time, because there's only one line. We can even go back and see where did that 500 come from. This is the thing that actually stored it. So it stores hex 500 right up here, and sure enough, hex 500 was in EAX here. It's an absolutely timeless debugger. I can click here, I can step forward, but I can also step backwards. I can also jump around. This is a loop. You can see that it's been in the loop 5 times. You see the 5 red lines? How many times did we go through the loop? 5 times, right? So let's actually solve the problem. Go to this compare, hex 500 in decimals, 1280. Netcat, 1280, winner. Now, when I go back here, see how there's 2 traces. Bring this main back up. We're still in trace 0 right here. But when I go down here, on the first trace, it went that way, but if I mouse over to the second trace, it went that way. Timeless debugger. Now look, this has been developed, started out by me, a bunch of people at CMU started doing some work on it, but imagine a real company that makes debuggers put resources into something like this. And you ask yourself, oh, you can't do this because there's lots of overhead. That doesn't matter. This is the modern world. Most code runs so quickly on mobile devices. If you have 100x overhead on a desktop, that would be totally fine for debugging, right? This has 2 backends, so what's actually doing this is QEMU, or you can also use pin. But yeah, like, why do we still have debuggers from the 70s? Future of the project, like I said, some guys at Carnegie Mellon are working on it. BAP, Anger, there's a bunch of these very nice static execution engines right now. The thing that makes them so difficult to use really largely comes down to UI. A lot of times it's exploring this code path that no sane human would ever explore, but there's no good way to prune it. Imagine integrating that with Kira saying, hey, stop exploring over there, right? Imagine being able to do this all in real time. By the way, Kira is all free and open source. Go to kira.me. What I was demoing there was Trunk. There's a release version on there. And both of these, I mean, so 2014, I won Secu Inside by myself. Team Tom Cruise, walked away with a $30,000 check. It was real nice. How did I do it? How do I get that kind of leverage? Well, one of the big ways was this tool. If you're running the binary 10 times less times than everybody else, it's quite helpful. So, how many people followed that? Try it out. Go to kira.me. Really cool. Now we're going to talk about something new. Security is a losing battle. That's true. I mean, the security industry's incentives are incredibly perverse. And people will talk about this, but right, the goal of a security engineer should be to put themselves out of a job. You know, true story, Sony in 2006, when they released the PlayStation 3, came out with phenomenal security, better than any product I've ever seen on the launch day. So Sony asked the guys, hey, is the product secure? Yeah, it's very secure. We worked very hard on it. Oh, cool, you're all fired. You have security, right? You're fired. This is literally what they did, and the PS3 security never improved, right? One of the reasons the iPhone continues to get jailbroken is because the iPhone shipped with no security. Everything ran as root. You could basically just issue a copy command to do a jailbreak. Because they rolled out security incrementally, you know, we could keep up, right? Today, the iPhone is by far the most secure platform, and that's reflected in the $1 million jailbreak price these days, right? I don't do jailbreaks anymore. It's $1 million, nation states. You get killed over that kind of money. It's true. So I'm retired. I'm out of the hacking game. Because honestly, if you want to solve security, the way you need to solve this is with things like sat solvers. You need to prove things secure, and really where this proof should kind of happen is in the language. Why do languages let you write insecure code? And there's a lot of nice compiler enhancements being put out to mitigate certain classes of attack, but can we just mitigate, okay, logic bugs, fine. Logic bugs are always going to exist unless you have a formal spec. But the fact that we still have memory corruption in 2016, I think some people really want to stay employed. That's really what I think. Come on, it's not that hard. But yeah, so I'm retired from hacking. I'm on to the next challenge, which is kind of related to this stuff, artificial intelligence. And now, for the remaining 4.5 minutes, I'm going to pitch you on my company. We are Comma AI. You see the comma on my sweatshirt? It's completely unrelated to security. But it's a table conference, so this is a chair conference talk, like I said. Comma AI. I have a self-driving car. It's true, it's in my garage at home. And it's better than Tesla's self-driving car. Literally, it works. Put some deep learning, threw a computer in the back of the car, rigged it all up. There's a great Bloomberg article about this. You can watch a video of my self-driving car. And if I can build a self-driving car, why don't you all? How many people here have a self-driving car? How many people here have a Tesla? All right, how many people have a non-Tesla self-driving car? Nobody, right? So why don't you have self-driving cars? And it's because people are dumb. Uber. I don't understand Uber's play in the self-driving space at all. Because Uber has to get to cars that can drive with no people. Let's say they solve 99% of driving. 1%, they still need a guy to sit there with a license in the driver's seat. So imagine Uber, right now they hire people to drive cars. Well, no, they contract people to drive cars. Imagine them instead saying, we're going to pay you to sit there 99% of the time and only drive 1% of the time. It saves them no money. It saves them no money unless you can do it remotely. I really don't understand the Uber play. The Tesla play makes a lot more sense. Tesla released this thing called autopilot. It's great. This is how you roll out self-driving cars. So if Tesla has everything right, why are they on my people are dumb slide? Well, first off, they didn't build a lot of it themselves. Tesla doesn't have a cafeteria. It's true, not even a cafeteria where you pay for food, they just don't have a cafeteria at all. So how do they expect to retain top-tier engineering talent? Right? So what Tesla did, because they didn't have talent, they partnered with a company called Mobileye. Mobileye is a 90s-era computer vision company. They make these little chips, and the CTO of Mobileye brags about his little chips and how they use 2.5 watts instead of NVIDIA's terrible 10 watts. By the way, NVIDIA really uses more like 15 watts, but NVIDIA's great because in a car, my car is a 200 horsepower engine. That's 150,000 watts. Who cares about 2.5 watts? Very 90s era thinking. Very dumb. But even dumb people are worth billions of dollars. This is Mobileye's stock. Their stock used to be there. Actually, it's now about $500 million lower since I mentioned them in Bloomberg in a not so positive light. But look at that, it's a B. Billions of dollars. So yeah. Check out this business plan, right? Check it out, check it out. Right now you pay about $2,500 for a navigation package in your car. For the same price, Comma AI is going to sell you, or your dealership, or your car OEM, a self-driving package. Now, you can go with this, or you can go with that. Who remembers the Kia Soul? Obviously, you're going to go with this. $2,500 a car. There's a couple million cars sold every year. We are going to be so rich. Here's a picture of a yacht, and now I'll take questions.